Hey guys, it's been a few weeks since I've uploaded my last video. I hope you've enjoyed that conceptual lesson about differentiation and derivatives. But here today, this is going to be a short one. I just want to show you one of my favorite techniques and one of my favorite integrals, indefinite integrals to solve because I think it's very intuitive and it uses your knowledge of trig and algebra and calculus to make something really unique and fun. So, what if I ask you this question? What is the indefinite integral of tan x dx? Well, this is not a known integral. This is not like, for example, let's say cosine x dx. If we take the antiderivative, you can't do reverse power rule, but you know that the derivative of sine is just equal to cosine. So therefore, the indefinite integral of cosine is just sine x plus c, right? That's not a super hard thing to wrap your mind around. But tan is a little bit more different. So let me show you. We can both agree that these are equal to each other. We just re-express tangent in a different way that might be more beneficial. And if you got spoiled by the header up here, integration by u substitution is the method in which we're going to solve this. So if you don't know what u substitution is, it's pretty simple. We're just going to let u, some variable, equal something in the equation. Now, what do we want? We're going to try cosine for our purposes. And then next, we're going to derive cosine. So we have du, and we have negative sine x dx. And we need to substitute du back into the equation. And if I rewrite this integral, where I bring out the negative because if I rewrite the integral as 1 over cosine x times sine x dx. Well, we see the sine x dx. We can substitute du in. Well, we need to substitute negative du in because that's a negative sine x dx. But here, it works, right? So we're going to have 1 over u because we are now substituting u, cosine for u, times negative du. But this is a constant. This is negative 1. By limit rules, we can bring that out to the front. And we can have 1 over u du. And this is a known derivative that we can do. You might try to do reverse power rule, but this is not going to work for this equation. As it probably didn't work for that one time you tried to take the derivative of 1 over x. Well, we know the derivative of the natural log of x is 1 over x. So therefore, the antiderivative of 1 over u should be ln u, natural log u. So we're just going to have natural log of the absolute value of u. Negative plus c, because it's an indefinite integral. Therefore, we do not know the constant. All right, so now we need to substitute cosine back in because that's what we set u as over here, right? And we can leave it here, but there's something we can do to make this, just put the cherry on top of this beautiful integral. We're going to write this. And you might be wondering, what happened to negative 1 and what happened to the cosine? Well, if you call back to your rules of logs, if you have a constant before a logarithm, you can put that as the power. So I just put the negative 1 as the power of cosine. I just put cosine to negative 1. That's the reciprocal of cosine. That's the secant. So therefore, our final answer, the indefinite integral of tan x dx is equal to the natural log of the absolute value of secant x plus c. Thank you for watching this video. If you have any more suggestions for lessons you want to learn, shoot them down in the comments below, and I will see you next time.